What is going on, ladies and gentlemen? Welcome to my channel. In this video, I'll be going over how to utilize Kafka with a Spring Boot application. It is not going to be a regular smegular application that has just one Kafka consumer and one producer all in one application. We will be creating two Spring Boot applications. One will be a gateway or act as a gateway and producing messaging, while the other application will consume the messaging from the gateway application. And we'll also be using Docker to spin up a Kafka instance so we can utilize it with our Spring Boot application. So let's get started. So what is the goal? Well, we know we're going to create two Spring Boot applications, right? We're going to have the gateway service and we're going to have the consumer service, right? And what this is going to allow us to do is going to allow for our gateway service to accept HTTP requests, whether that's from a UI or another server. Well, it's going to take that request and it's going to place that request and place it into a message in a format that we will construct and send it to our Kafka topic, right? And then now that the message is on the Kafka topic, well, now the consumer can consume that information from the Kafka topic and we can utilize it in whatever way that we want, whether that's logging in information, whether that's inserting that information to a database, whether that's sending or taking that message and sending an email based on what type of message. These are all things that we can do once we have access to the message that the gateway service sent to the Kafka topic. So we will get the full flow of this application going, right? We're going to have a controller set up in the gateway. We're going to send that information using a producer to the Kafka topic, and then we're going to consume that information from the Kafka topic and utilize it in whatever way that we want. So that is the full goal, right? We're going to get the full capabilities of different applications, different microservices, and Kafka. So what do I recommend? Well, I do recommend some Spring Boot knowledge, and you don't need to be a pro, right? Some basic knowledge will do. And I do have a couple of tutorial videos on my channel if you want to check it out to get an understanding of Spring Boot. I did a full flow of how to connect a database and how to utilize Spring Boot and how to create a controller, how to create an API using Spring Boot. So that's all on my channel. Also, I do recommend some Kafka knowledge. I just created a Kafka component tutorial video which goes over all the components within a Kafka cluster, so you guys can watch that to get some information on that. And then I also recommend some basic Docker knowledge because we will be using Docker to spin up a Kafka container and Zookeeper container, but you don't need to be a pro. Just some basic knowledge on what a Docker Compose file is and how to set it up will be useful, and I will go through it step by step on what each piece is doing, but just some basic knowledge will help this tutorial video go a little bit smoother. And what you will need, well, you're gonna need Java because we'll be using Java with our Spring Boot application. We'll be using Maven as well, but you will need Java or the JDK on your device that you'll be utilizing. You will need an IDE. I recommend IntelliJ because the ecosystem for Spring Boot is great on IntelliJ, so I recommend it. But you can use whatever IDE that you're comfortable with. And lastly, you'll need Docker because, like I said, we'll be utilizing Docker to spin up Zookeeper and Kafka, so Docker will be important in this case. So these are the three things that you will need. So now let's get started. The first thing that we'll need is to get a basic template of our Spring Boot application that we'll be utilizing. So that's going to be the gateway and the consumer. So let's switch over to the Spring Boot Initializer website where we'll download two instances of our Spring Boot application. Alright, so if we make our way to the start.spring.io website, this will be the Spring Initializer, and it will allow us to create the template for our application, our Spring Boot application. So we'll be creating two Spring Boot applications because, like I said, we'll be utilizing a gateway application and there's going to be a consumer application, right? Whatever the gateway sends to Kafka, the consumer application will retrieve from Kafka and do some logic with it. So first, let's choose what type of project we want to utilize. So I want to utilize Maven. I know some people like Groovy or Gradle Groovy and Gradle Kotlin based on whatever you want to do, but I like Maven. And then we're going to utilize Java as the language, and then for the Spring Boot version I'm just going to use the default version, which is 3.1.2 at this current time. Now for the group, you can leave it as com.example if you want, but I'm going to do com.twg, and then for the name I'm going to make this twg-gateway. Actually put a W, right? The name will be also the same name as the artifact, so it's going to be twg-gateway, and this is going to be a Spring Boot gateway, right, for the description. And then the package will just be com.twg.twg-gateway, which is just the addition of all of these together. Then the packaging will be jar, and I'll be using Java 17. I'll leave that as a default, but 20 is available if you want to, or 11, but I'll leave it at 17. Now for the dependency section, let me add some dependencies. I want to do Lombok because it will allow us to use some annotations that will make our coding experience much more easier, especially when creating getters and setters and creating constructors. This Lombok dependency will allow us to use some annotations that make it way more faster. Then what I also need is Spring for, or let's put Kafka because that should be faster. But it's going to be Spring for Apache Kafka, so it's going to allow us to utilize some of the internal methods for publishing, subscribing, and processing some of the records. So we'll be utilizing that for the producer, which is our gateway, and for the consumer, which will be the thing that I create next. And really, that's all we need. But if you were, trying to make this more advanced, right, you could, add in dependencies for like things like Postgres and stuff like that. If you're trying to get information from a database, this will be the place where you get those dependencies. But in this case, we need Lombok and Spring for Apache Kafka. Now let's press generate, and we should see that it's going to start downloading the template for our Spring Boot application based on these configurations that we just set up. So good. Now we can start creating the template for our consumer. So really, there's not going to be much to change. I still want to use these two dependencies, and I'm going to keep it as that. The only thing that I want to change is just the artifact name. So instead of it being twg-gateway, it's going to be twg-consumer. So that's what I'll be doing, and changing the description to a Spring Boot consumer. Right? So the project is still going to be Maven, the language is still going to be Java, the version is still going to be the same, 3.1.2, which is the default at this time. And then, I just changed the metadata to things that relate to the consumer, because this is going to be the consumer application, and the packaging is still going to be jar, the Java version is still going to be 17. And like I said before, these are the two dependencies that I want to utilize. But if you want to add other dependencies, you can just press this add dependencies button and do that, right? Like I said, say for instance, you wanted to use a database like Postgres to store all the messages that are coming, or you want to configure it and then store it, you could add the Postgres dependency, and when you generate this Spring Boot template, it will have that dependency for Postgres. But we're not doing this in this tutorial, maybe in another one. But yeah, let's generate this really quick. And now we have the consumer and a gateway. Now let's open up IntelliJ and start constructing our application for the gateway. Alright, so now it's time to utilize the templates that we just created. But before we do that, make sure that you open up Docker Desktop, right? Because Docker is a requirement for what we'll need, because we'll be utilizing Docker to spin up a Kafka and Zookeeper instance. So make sure you have your Docker Desktop open, and if you're on a Mac, you should see a little Docker icon on the top right. And if you're on Windows, well, you should just see the GUI. The GUI will let you know that you have your Docker running, and this is green right here. This engine is running, so we should be good to go on that front. And make sure you have chosen an IDE. In this case, I recommend IntelliJ, but you're free to use whatever you're comfortable with. And now we should open up our producer or our gateway project, right? Because we've created two templates from Spring Initializer. We created the gateway project and we created the consumer project. We're going to start off with the gateway project, and we're going to put our Docker compose file inside of the gateway service so we can utilize it to spin up our Kafka instance. But let's actually open it up, and once I have it opened up, we can start. Alright, so now we have IntelliJ open with our gateway project, and IntelliJ already created a .idea folder, which is specific to IntelliJ. It's what it would need to do its thing, to keep it running efficiently. Then we have the .maven folder, which is a wrapper for Maven. We have the .source folder, which is going to be where we work from. And inside the source folder, we're going to have main and test. So inside of main, we have the Java folder, and if we go a little bit deeper, we see a package associated to the TWG gateway application. This is going to be the entryway to our application. So we run the application from here, and it starts it up from here. And then if we have any resources, we place it within the resources folder. We have an application.properties file, which we can set up, different properties for our application here. Like if we want to start the server on a different port, we could do that here. Or if we want to set up some Kafka configurations, we could do it here. There's many things you could do with this file. We won't really be utilizing it because I'm gonna create a separate file for the Kafka configuration, but you are able to do it from there if you need to or if you want to. And then we have the test folder, which, as the name implies, is for test, right? So if you want to write some tests, you do it from here. Cool. Now I'm gonna close this all up, and there's some other things that we can use. We have the .get_ignore and some other things like the pom.xml, which we can put some additional dependencies if we want. But what I'm going to do right now is I'm going to right click on the parent folder, which is this twg-gateway, and it's going to be called 2 because I have another one, but whatever name that you put during the SpringBoot template setup that I did initially will be here. But right click on that, that's considered the parent folder. And what we're going to do is create a new file, and I'm going to put the name docker-compose.yml. This is going to be a YAML file because we're going to utilize Docker Compose to create different Docker services, right? And the services that we're going to create is one for Kafka and one for Zookeeper, because Kafka is dependent on Zookeeper as of now. But if you watch my Kafka Components video, we do talk about how Kafka is moving away from Zookeeper, and they have their own in-house metadata configuration that will be replacing Zookeeper. So if you want to know more about Kafka and the components, then you can go ahead and watch that. I'll leave a link somewhere on the screen or in the description. So the images that we'll be using for creating our Kafka and Zookeeper container is the Confluent Docker image for Kafka and Zookeeper, right? So they have a stable version of Kafka and Zookeeper already created for us. So now we can just pull that image and create a running container for those services, right? And we'll be utilizing a single node Kafka server, so meaning we're only going to use one Zookeeper instance and one Kafka instance. It is possible to use a multiple node cluster version, meaning there would be multiple instances of Zookeeper and multiple instances of Kafka. But for this tutorial, I'm going to keep it simple and just do one. But there are many reasons why you shouldn't use one. You should use multiple because of the fact that with multiple, there's that scalability factor, right? There's that replication factor, meaning we can store partitions on various versions or various different brokers, right? And with that factor, you handle essentially failovers, right? Because if there's only one node and if that one node fails, then we lose all the data, right? Because all that data that was on that one broker is gone. But if we have multiple clusters, then that means we can put data on different versions, and that take care of failovers, right? Because with one node, if we lose that one broker with all the data, then we lose a lot of data, right? But if we have that data on multiple brokers, then if one goes down, then the other brokers pick up the slack, right? And then there's that availability, right? If one broker goes down, then that means until that broker issue is resolved, then we have time in between where messages are coming in and we're unable to handle those messages because the broker is down. But if we have multiple brokers, then they will pick up the slack and take those messages until that broker is back up and running. So in the future, I will create a tutorial on how to create a multiple broker setup. It's not too hard, but just for the people who are just getting started with SpringBoot and Kafka, I wanted to make it as simple as possible. So enough talking, let's actually create the Docker Compose. So the first thing I'll be creating is a Zookeeper server, which always has to start before the Kafka server because Kafka depends on Zookeeper, and like I talked about in my Kafka Components video, there are things or there are approaches that Kafka are taking that is going to remove the dependency of Kafka on Zookeeper. But you can watch that video to get that explanation. I don't want to make this video too long. But what we'll be doing is creating a Zookeeper server, and we'll have it listed on port 2181. Alright, so let's get started. I will be pasting in the Zookeeper portion of the Docker Compose just to make it a bit quicker, but I will be going over line by line of what each individual thing is doing. So let me just start that, paste that in. The version of the Docker Compose is 3.8. That is the latest version. And yes, there is version control for Docker Compose. The services is the section that we'll be using to signify the containers that we want to spin up when we do start this Docker Compose. So in this services section, the first thing I'm going to create is the Zookeeper section, right? And we signify that this Zookeeper will be utilizing this image, right? The image I will be using is the Confluent Zookeeper, which is created by Confluent. It's just an instance of Zookeeper that they manage, and we're going to be using the latest version. We can signify that by using a colon in between. So it's Confluent inc/ cp-zookeeper, and use a colon to signify that we're going to be using the latest version that Confluent has to offer when it comes to Zookeeper. And then the container name will be Zookeeper. It can be anything, but I just want to keep it obvious, so it's going to be Zookeeper. And then now we can start going into the environment variables that's in this environment section, right? The cool thing about IntelliJ is that you can see like what each individual tag is about, right? If you hover over it. So environment just defines environment variables set in the container. So the first one is going to be the Zookeeper server ID, and this is just a unique ID associated to the server. So if I made another Zookeeper server, then I can't use one again. Got to use 2, 3, etc., etc. And then the next one is the Zookeeper client port, which is signifying that the port is going to be 2181. And then the Zookeeper tick time is going to be 2000, right? That's going to be milliseconds. The tick time is just a basic time unit in milliseconds used by Zookeeper. It is used to do heartbeats. So heartbeats is usually used to, check if the server is still running, and is also used to define the minimum session timeout, which is going to be double of the tick time. So right now it says 2000, but double of 2000 is going to be 4000. So that means the session timeout will be 4 seconds, 4000 milliseconds. And then lastly, we're going to define the ports. So on the host machine, it's going to be 22181, and then within the container is going to be 2181. This is going to be utilized by Kafka, right? Because Kafka is going to be within the container, so it's going to be utilizing the 2181 that Zookeeper will be listening on. Then lastly, we have the ports. So we're going to have 22181, which is going to be the port exposed to the host, and then we have 2181, which is going to be exposed to the container. So cool. Now we have Zookeeper set up. The image is going to be coming from Confluence, and then we set up the container name, the environment variables, and the ports. Now we can start creating the Kafka portion. All right, so let me make some space and then make sure that the name is aligned with the previous service, which is Zookeeper, and paste this in. And now we have our Kafka portion, right? And I'm just calling it broker. The image is also coming from Confluent. And it's Confluent inc /cp-kafka, and then colon. I'm going to be utilizing the latest version as well. The container name will be broker. You could put Kafka broker or whatever name that you want to put. I think broker just makes a lot more sense to me. The ports that it will be exposed to is going to be 9092 for the host and 9092 for the container, and it's going to be dependent on Zookeeper, meaning Kafka is dependent on Zookeeper, so we do have to wait until Zookeeper is spinned up and running before we can create our Kafka broker or our Kafka cluster. So that's why I put this depends on tag, and if we hover over it, it expresses startup and shutdown dependencies between the services. So we're going to wait for the startup of Zookeeper before we can start up this Kafka cluster, right? And then we have the environment variables, right? And there's a lot more than Zookeeper. So the first one is pretty much the basic Kafka broker ID, and it's the same logic as the Zookeeper server ID, meaning that it's a unique ID associated to that broker. And in this case, there's only going to be one broker that we're going to utilize for this tutorial, so I just left it as 1. But if we create another broker, then it will also have to be unique, meaning it'll be 2 or 3, whatever value that we give. It just has to be unique. Then we have the Kafka auto create topics enable, and that's set to true. And when we set this value to true for this environment variable, it just allows brokers to create topics when they're first referenced by the producer or the consumer. So we're going to be using SpringBoot, and that's going to allow us to create the topics on the fly when we do spin up our SpringBoot application. If we had this to false, then we would have to use the Kafka CLI to go in and create a topic, and it wouldn't allow us to create a topic on the fly. We actually have to go in and do it. But with this enabled to true, then we're able to create the topics whenever we want. So in our case, it's going to be when we spin up the SpringBoot application. So perfect. Then we have the Kafka Zookeeper connect, which, as the name implies, it just instructs Kafka how to connect to Zookeeper, and we're just going to use Zookeeper :2181. It knows that Zookeeper is associated to this Zookeeper container, so it's just saying Zookeeper on port 2181. It just makes a lot of sense, right? Instead of writing it all out, just reference Zookeeper, which is up here, and go look for port 2181. Then we have the Kafka listener security protocol map. This just defines a key value pair for the security protocol to use per listener name. So in this case, we're just defining it as plain text for the key and plain text for the value. Then we have the Kafka advertise listener, and this just makes Kafka accessible from the outside by advertising its location on the Docker host. It can be comma separated, utilizing a list of listeners with their host IP and port. And this is just going to be metadata passed back to the clients. So in this case, we're just using plain text and the port or the host of localhost and the port of 9092. And then lastly is the Kafka offset topic replication factor, which is just required when we're running a single node cluster, because we're going to define one cluster. If we were utilizing 3 or more nodes, we can use the default value, meaning we wouldn't need this. But since we're only using 1, then we have to signify that it is just going to be 1. So that is all the environment variables for Kafka, and that's how we're going to spin up our broker or our Kafka instance, and that's how we're going to spin up our Zookeeper container. So now all we got to do is go into the terminal, right, and just do a simple command of docker compose up -d, and also make sure that it's in the same folder as the docker compose. If it's not, then it's not going to work. If it's in the same folder, then we're good to go. Use docker compose up. Also make sure your docker is running. If it's not running, then this is not going to work either. And I'm using the -d because that just means detached, meaning that it's going to run in the background. It's not going to start logging all the docker stuff in this terminal. So it's going to be running in the background because we may want to use this terminal in the future. We don't want to log all the information here. If you do, then you just remove the -d, but I want it to be detached in the background. Press enter, and it should start spinning it up. I'll be back. Alright, so it is finished, and I am back on the Docker desktop GUI, and if it ran successfully, because if I go back to the terminal, it says that Zookeeper was started, and then the broker was started, right? And then if I go to this GUI, I can see that, oh, this gateway has 2 containers running, and boom, we got the broker running and we got Zookeeper running. So we are good to go. Now that we have that set up, now it's time to actually start creating some configurations for Kafka, because Kafka is running now, so we can start creating what we need to start. So now that that's up and running, we can now create the configurations that we'll need to interact with Kafka. So let's create our Kafka config, and let's go to main Java, and in here in this com.whatever package you named it during the template structure, but in this case for me it's com.twg-twg gateway. What I'm gonna do in this package, I'm gonna create a new package, and I'm gonna call it config, because this is where all my configurations are going to be stored. And inside of this package, I'm going to create a new Java class, and I'm going to call this Kafka config. Now, within this file, we'll create a topic to automatically add to the broker once the application runs. So once this application start, it's going to create a topic automatically to Kafka. And like I said, this is going to be a config file, so we can let SpringBoot know that this is going to be a configuration file, so we can use the annotation configuration. And then within here, we can start creating a bean so that Spring Boot can pick up that we need to create a topic once this application starts up. So we'll use the @bean annotation, bean, and we'll do public new topic because it's going to be a new topic type by Kafka. You can see it. Boom. Import that. And we're going to call this transaction topic. Because the whole point of this application, right, hypothetically, right, we want this gateway to take in different transactions, right? We're going to set this up nicely, but we want this application to take in different transactions. There's different transaction types. It could be a deposit, it could be withdraw, whatever. But all those transactions are going to go to the transactions topic, which is why we're calling this transaction topic. So we're going to return a topic or instance of a topic builder, right? Because this topic builder is going to allow us to first give it a name, which in this case we use the .name method and we pass a string, and we're going to call this transaction-topic, and it's going to allow us to add other configurations like the amount of partitions that we want, like how we want to split this up, or how many partitions do we want. If you don't know what a partition is, like I said, I created a Kafka component video. You can go check that out. But essentially, it's pretty much how we split up the data, right? So in this case, we want to create 2 partitions, right? I want it to be split up between 2 partitions. And then the amount of replicas, right? Let's do 2 as well. And then after that, we gave it a name. We gave it the amount of partitions, the amount of replicas, and then now we can do build. And make sure you put a semicolon at the end, because this is Java. You need to put semicolons. So now we have this topic that will be created with this name, with this amount of partitions, with this amount of replicas on the creation of this gateway application once it starts up. Now, we do not have to specify the amount of partitions or replicas, especially after version 2.6. But if you know what you want, then you can add it just like I just did, right? You can put the amount of partitions and the amount of replicas, but these aren't required. You can do it without it. But I want 2 partitions and replicas. And just for future reassurance, or just to know, right? If you want to create multiple topics, then we can create a new topic builder with different names, or there is even an object called a new topic, or new topics with an S, plural, that takes in multiple topic builders. So let me just copy and paste an example that I already had, just for you guys to know for future reference, right? So if I paste this below here, you can see, and this will require the Kafka admin. Like, Kafka has different APIs. I don't want to keep plugging in the video that I created, but I do talk about the different APIs that Kafka has, and admin is a part of it. But this will allow us to create multiple topics at one time, right? So it's going to be Kafka.newTopics, and then we'll see that we can start creating or utilizing the topic builder to create multiple topics. So we have one for, say for instance, if we wanted to do a withdraw, we can do that. Deposit, fraud, each one of these will have or create its own individual topic within that broker. And like I said, you don't need to use partitions and replicas, or you can either just use one or the other, right? You can use both. You can use just replicas, you could just use partitions, but yeah, this is how you create multiple topics if you need it. But it's not what we're going to be doing in this tutorial, so I'll erase that, but it is possible if needed. So now we have our configuration that we need to create a topic when this application is ran for the first time. But now let's dive a little bit deeper on what type of message we're going to be sending to this topic from this application. So we're going to need to define a model, because this model is going to be how our message is going to be structured and how it's going to be sent to this transaction topic. So let's go here and let's create a new package again, and I'm going to call this model, because, or models with a plural, because this is where models are going to be stored. And in this case, I'm going to create a new Java class, and I'm going to call this transaction message, because this is going to be a message that relates to transactions. So we have transaction message created now. I want this application to be based on transactions like Cash App, Venmo, PayPal, The users can send different transactions, events to the topic. The consumer can consume from the topic and do logic based on the type of event. So this is what transaction message should reflect. We'll be using Lombok to provide boilerplate code by just passing a couple of annotations. So the first thing we're going to do is use @data, which is a Lombok annotation. Right, boom. And a data annotation will provide all the non-final field helper methods such as getters and setters, toString, equal and hash code. All that is going to be added to us or added for us without having to create it ourselves through this Lombok @data annotation. So all the convenient methods that simple plain old Java objects usually have, we don't even have to write anymore. It saves a lot of time. Then we're going to have another annotation called all arg constructor, which is going to create constructor for us for all arguments, and we're also going to use a no arg constructor, which is just going to utilize or create a constructor for us with no arguments. And now we're good to go. Now we just have to create the fields within this transaction message that we want to accept. So the first one I want to create is a private long transaction ID. This will just be a unique ID for each transaction going to the topic. The second one will be a event type, and this is going to be event. This event is just going to be enum that defines the type of transaction, whether it's a withdraw or a deposit, and I will signify that by going below here, make a public enum called event. Open that up, and it's just going to be withdraw and deposit. Cool. Then we're going to have a private float amount, or actually let's make this a double just for more precision, and that would just be the amount that the transaction is being sent for. So it could be a withdrawal of 1,000 or a deposit of 500, whatever, but this would just be the amount, and it has to be a decimal, so that's why we're using double, because there can be 100.50 and 100.60, stuff like that, right? So, and then the last thing we want to do is use a private field of status. This is going to be also another enum, right? And there are different statuses for a transaction, right? A transaction can be submitted, it can be started, it can be pending, it can be finished, it can be terminated. So this will be what status stands for. So it's going to be public enum status, and we can start defining some of the statuses that we expect. So submitted, started, pending, finished, terminated, right? In the case of fraud, stuff like that, it can be terminated. So now we have a transaction message. It's going to take in the transaction ID, events, it can be withdrawal or deposits, the amount of the transaction, and the status, right? It can be submitted, started, pending, finished, or terminated. So now we have our model for creating our Cash App Venmo clone, right? Because we're going to be sending transactions to our topic, and on the other side, the consumer can accept those messages or that transaction message and do different logic, right? Maybe we want to send an email to our customer saying that we got that transaction message, deposit is going through, or it was finished, or different events like that. Kafka can send millions of messages without any issue. And speaking of sending a message, we will utilize a Kafka template to send a message to the broker we just created, right? The Kafka template wraps a Kafka producer and provide convenient methods to send to the Kafka topic that we just created. The method that we will use will take 3 parameters, right? It's going to take the Kafka topic name, the key, and the message, right? Because we have to know what or where we're going to send the message to. We're going to provide it a key, and we're going to provide the value, which in this case is going to be transaction message, which we just created. To utilize the Kafka template, we have to configure a producer factory. So what we're going to do right now is we're going to create a new config. It's going to be a Java class. It's going to call Kafka producer config. And this is how we're going to configure the producer with what we need, right? We're going to create the producer factory here, and we're going to provide it to the template, the Kafka template constructor, which essentially will start up or create exactly what we need so we can start utilizing the methods that the Kafka template comes with. The producer factory essentially has all the configurations of the producer, including the type of serialization, which is dependent on the type of message, right? So if we're going to be sending a transaction message, which we just created, I want the serialization to be a JSON type. So let's start writing it out, right? This is going to be another configuration. So let's do the annotation of at configuration. And what we're going to do is I'm going to create another bean. And this is going to be a public producer factory. All right. You can see that it's coming from Kafka core. And we're going to start defining first with this factory. The first thing is going to need to know is what type of key is it going to be. I want to make it a UUID. And what type of message we're going to send. And actually, before I do that, I got to import the UUID library, which is going to come from Java util. And then what type of message I'm going to send, which we just created the message type. It's going to be transaction message. And I'm going to call this producer, if I can spell properly, producer factory. Open that up, and now we can start defining the properties or configurations for the producer. So we're going to create a map. Open that up. It's going to be a string and an object, right? Because it's going to be a string and an object because we're going to start defining different configurations, which is going to be of type string, and the value is going to be an object. And I'm going to call this config props, and this is just going to be a new hash map. I love hash maps. And then end that with a semicolon, and I forgot to import map. All right, cool. We should be good to go. Now, the first config that I'm going to put into this map, so I'm going to do config props.put, and what it's going to take is, like I said, what type of config we're going to do, or what type of config are we trying to configure. Well, it's going to be a string, right? Because what we're going to do is we're going to do producer I've got to spell it properly, producer config dot, and there's different configs that the producer have that we can utilize that are going to be constants, but those constants are strings. So the first one we're going to set up is bootstrap server config. That's going to be the key name, and that is a string. Because if we go in, let me go in a little bit deeper. In this producer config that Kafka provides, we see that there are different constants that Kafka allow us to configure for the producer, and within those constants are strings, right? So here you can see that for bootstrap server config, it is a string called bootstrap.servers. Now if I go back, the bootstrap server config is just a URL of one of the Kafka brokers, which we'll give to fetch the initial metadata about our Kafka cluster. So this metadata consists of the topics that are in the cluster, the partitions, the leader broker. And since this is a single node cluster, there's only one leader. There's only one broker, right? But it'll still say it within the metadata, the leader broker for those partitions. So this configuration is pretty important because it does the setup of making that connection between the producer and the Kafka cluster. It gives it vital information that we'll need to send the message. So we know that our Kafka broker is being exposed on localhost 9092, right? Because that's what we exposed when we created our Docker container for Kafka. So cool, now we have one of the configurations set up. Now let's create another one. So we'll do config props.put, and it's going to be another string key. So we're going to do producer config dot, and we're going to do key serializer class config. And what this is, what a serializer is the serializer will convert the data into bytes to send to the topic and save the state of the object. So when it becomes deserialized, it maintains the same format. So what we want to do is we want to send the transaction message, but when the transaction message is being sent over to the topic, it's going to be converted into bytes, right? Because Kafka runs or understands bytes, right? And then when the consumer goes into the Kafka topic and tries to retrieve that message, it needs to know what format was the original version of that message. So for this serializer class, we're essentially going to say that this was originally a UUID, because for this one we're defining the key serializer. So the key is going to be UUID. We specified that here. So when the consumer goes in and see, okay, what type of key was this originally? We see the bytes in the topic, but what was this key originally? Well, I want to specify that this is a UUID serializer. So we'll do UUID serializer dot class, so that when the consumer goes in and see, okay, this key was a UUID at one point, we can deserialize it to get the original format, which is UUID. So yeah. And then we can do the same thing for message, right? Because like I said, everything sent over to the topic is sent over or serialized into bytes, and we need to know the original format. So for the first thing, which is the key, we serialized it into bytes, but originally it was a UID. So when the consumer goes in and try to retrieve the key, it'll know that this was originally UID. And for the message, we'll set that up as well. We're gonna do config props.put, and we'll do producer config dot value serializer class config. Well, we want to send it over as a JSON, right? We want to send our message as a JSON, so it's going to be JSON serializer dot class, right? So it's going to send the message as a series of bytes and store it in the topic, but then when the consumer consumes that information from the topic, it's going to be originally, you know, a series of bytes, but when we deserialize it, because we're serializing it, right? That's the important word to understand, serialize. We're converting it to a series of bytes, putting in the topic. It's being stored as a series of bytes, but then when we want to destructure that and convert it to the original type, which we're specifying here of what the original type was, JSON for the message and UUID for the key, well, now the consumer knows how to deserialize it, right? It knows how to convert the bytes to the original format. So that's a very important concept to understand when it comes to Kafka. So we know that the value, or in our case transaction message, will be deserialized because originally it was serialized, or it was serialized as a JSON. So it's going to be deserialized as a JSON as well when we get to the consumer portion of the application. Hope that makes sense. If it doesn't, then you can leave a comment down in the comment section. I'll try to answer to the best of my ability. And now we have all the configurations that we need, so we can just return a new default Kafka producer factory, and then put in the config props as the configuration that we just set up. And I just spelled this wrong. Default Kafka producer factory, right? Because we said that the type is producer factory, and we're going to send a default Kafka producer factory, and this is just ruin the whole format of it. Let me erase that piece, and now we should be good to go. So now we can create another bean, and we're going to create a Kafka or instance of a Kafka template, which will allow us to utilize all of the methods that a Kafka producer has, right? So we can specify that the key is going to be UID, and the message or the value is going to be transaction message. We're going to call this Kafka template. Open that up, and we're going to return a new instance of a Kafka template. Kafka template, and it's going to take in all the configurations from this producer factory function that we just created as the constructor. So we see what's being returned. What's being returned is a default Kafka producer factory, but with all the configurations that we just set up. And don't forget to put this semicolon. So it takes that as a constructor. So now the Kafka template is going to allow us to utilize all the methods that a producer have to offer. So if I go into Kafka template, right, we see that it takes in a producer factory as the constructor. It's going to create a new instance of that, and this is a pretty big file, but there are so many things or so many methods that it has to offer, right? So we can start utilizing all of this because now we created a new instance of the Kafka template, utilizing the producer factory with all of the configuration that we need to communicate with the Kafka broker that we created, right? Especially with this bootstrap server config, right? We know that it's being hosted here, so then now we can, send what we need to, right? And we're going to be utilizing this one right here, this sends. So all we need to do is use Kafka template.send, pass in the topic name, pass in the key, which is going to be UUID, and then pass in the data, right, which is going to be transaction message. And that's why we had to describe, what type of UUID it is, or what type of key it is, which is going to be UID, and what type of value is going to be, which is transaction message. So it knows to populate that now for key and for value, which in this case is going to be data. And now we can produce a message. Hope that makes sense, but if it doesn't, like I said, leave a comment down in the comment section. Alright, so now that we have the template created, and now that we know that we can utilize the methods that the template has to offer, we can now create a service, because we will be producing a Kafka message when a HTTP request is sent to the gateway. So we'll utilize the service in our controller to send a message, right? So we'll create a class called a Kafka producer service, and we'll use the service annotation to let SpringBoot know that it is a service. So let's do that really quick. I like to put my things in packages to keep it organized. So we'll create another package called services, and this is where the Kafka producer service is going to be stored. Kafka producer service, and like I said, we'll use the @service annotation to let Kafka, or to let SpringBoot know that this is a service. Let's now auto-wire our Kafka template, which we configured, which will allow us to utilize methods to send data to the transaction topic. So let's do that, auto-wired. Let's do Kafka template, and we'll just call this Kafka template. And we gotta give it a type actually, so give it UUID for the key, import that, and transaction message for the value. And I also want to utilize a logger so I can see what's happening when using this service. So let's do private final logger, and we'll just get that from the SLF4J, and we'll just call this all caps logger, make that equal to the logger factory dot get logger, and we got to give it a class and what we're going to create this logger from. So Kafka producer service dot class, put a semicolon at the end, and we should be good to go. Now we're going to create our function, which will allow us to send information to our topic. So this is going to be a public void, because I don't want to return anything, I just want to send it. And then, like I said, we're going to be utilizing the method that has 3 parameters, which at first is going to be string topic name, because we got to know what topic to send it to. Then it's going to be a UUID type of key, and then it's going to be a transaction message as the value. So I'm going to take that as a parameter and open that up. So now we're going to have a variable, or var, called future, and that's going to be equal to Kafka template dot send, and we're going to pass in those 3 values that we just took in: topic, name, key, and value. Now really, taking in the topic name, if you know you're only going to use one topic, you could probably just make a constant here, but for future reference, if you have multiple topics, like I just showed in the beginning, of how you can create multiple topics, then this would kind of make that future proof in the sense that you can pass in that topic name and it would just send it to that individual topic name instead of just restricting yourself and making a constant here. And actually it's not value here, it's transaction message. And then put a semicolon. But yeah, you can choose to put a constant here if you want, but I just made it future proof by allowing you to specify the topic name in the future. So then we have the future. So this future is returned as a completable future, right? And a completable future signifies that the future variable will hold the result of an asynchronous operation that is being executed on a different thread. So it's not going to happen in one go, right? It's going to let us go to the next line and do whatever we need to, but that don't mean the result is being stored in future yet. It's doing its thing on a separate thread, and in the future it may return a value, but we want to make sure that we handle what's being done, right? Whenever a Kafka topic is being sent, we want to make sure that it was sent successfully, and if it was a failure, right, if the broker is down or something happened, that we handle that properly. So there is a method that this completable future come with, which is called when complete, which will allow us to know when an async action is complete. It has a callback which will let us handle exceptions, and if it's successful, then it will send result and log what was sent. So that's exactly what we're going to utilize and do. So let's do future dot when complete. Like I said, it comes with a callback, so send result will be a parameter. Actually, I got to open up another parentheses, send result, and the second parameter is the exception. So if there's an issue, then we are no, and then arrow, then open up some braces. And if exception is not equal to null, meaning there is an exception, there's something within this variable, then that means there's an exception and we got to handle that. So future dot complete exceptionally, and then we would throw that exception. And then else, right? If there is no exception, we're good to go. Then it'll be future dot complete and send the result. And I've got to put a semicolon right here. All right, so now it's time to utilize the logger. So it'll be all caps logger dot info transaction status to Kafka topic, and then make that lowercase and just do value dot status. Or I always say value is transaction message. That the value is the transaction message. So transaction message, and honestly I should probably put the ID somewhere. So the ID is, and then I'll just add that here, transaction message dot transaction ID. Then we'll append that. Boom. Let me add this on a new line. Get status. And we should be good to go. And then put a semicolon right here at the end, and boom. So now we can see that if there's an exception, then it's going to complete exceptionally. If it's good to go, then it's going to send the results. And we can even put a logger somewhere here. So logger dot, and we could put, there's different methods that this come with. So you can put an error one if you want, and then you can do exception dot get message. So yeah, that is how we can handle sending a message to the topic, and because it's an asynchronous process, we can make sure that we handle it when the async process is different. by using the whenComplete method, which essentially have a callback to see whether there was an exception or whether it was actually handled properly, and we're utilizing the logger to make sure we have an eye on what's occurring for each send. Say for instance there were 100 withdrawals and only 2 deposits, that might be a little bit suspicious maybe, or if there were different events that occurred, we can keep track of that. So this is usually how it's being approached, especially with Kafka messaging. So yeah, cool. Now we have the service to send the message, but now we have to utilize the send in our Kafka controller, right? Because we want to be able to send a message when an HTTP request comes in from the outside. So let's set up the controller really quick. So let's go into this package right here, and you know I like creating new packages. So let's call this controller because this is where our controller is going to be held, and do new Java class event controller. So one dependency that I actually did forget to add for our templates when we were creating the skeleton for applications in the Spring Initializer was actually SpringBoot Starter Web. And what this dependency is going to allow us to do is going to allow us to start building web and RESTful applications using Spring MVC. And we know we'll need that for the producer because we are going to be accepting API requests, HTTP requests to our application, specifically a post request. So we will actually need this dependency. So all I did was Google SpringBoot Starter Web. It brought me to this MVN repository. And what I'm going to do is I'm going to just go ahead and grab the latest version, which is 3.1.2 at the time of this tutorial. And then once you go here, you can see different versions for different dependency managers here. So you get one for Maven, which we did use, Gradle, Gradle for Kotlin. So depending on which one you chose, you can go ahead and click the tab. But since I chose Maven, all I got to do is click it, and it's going to copy the dependency for us. So now I can go back into SpringBoot and place the dependency so that we can get that in our applications so that I can make a RESTful application. So let's go over back to SpringBoot and add the dependency. So I'm back in the application. Let me go to pom.xml, and I'm going to be within this dependency section. So make sure you're within this section, and I'm going to put it before the test dependency. So I'm going to place it right after Lombok, and I'm going to paste it right there. I'm not going to use this. I'm going to take this comment out, and then I'm going to click this little Maven or load Maven changes button right at the top right, and it's going to start downloading the necessary dependencies in regards to SpringBoot Starter Web that will enable us to actually create a RESTful application using Spring MVC. All right, cool. So it seems like it's in sync now. So now we can actually go back and create our event controller properly. All right, so now that we have the necessary dependency, we got the SpringBoot Starter Web dependency in here, and it's in sync. Now we can go into the event controller, and now we can start creating our REST controller, right? Because this will be used as the entrance to our gateway application, meaning your UI or any other service that will be sending a transaction message will be going through here. And we will confirm that that message is in the proper format and send it to the topic using the service that we just created, which is the Kafka producer service. So to let SpringBoot know that this is going to be a REST controller, we can use the annotation @REST controller, which is coming from what we just added to our dependency, which is just coming from the SpringBoot Starter Web. As you can see here, it's coming from the Spring Framework.web, and it's the .bind.annotation, and it's the REST controller. Now we can auto wire, right, our Kafka producer service because we're going to be utilizing the send method that we created, right? Now, when do we want to utilize the send method? Well, we want to utilize it when somebody sends a post request to our gateway application. So to listen for post messaging, right, we could use the @post mapping, right? This is also coming from the Spring Framework.web portion of the application. And now we could define an endpoint that a UI or another service can send to our application by a specific endpoint. So we can specify the endpoint by opening up parentheses, opening up some quotes, and giving that endpoint a name. So in this case, it's going to be /event. So now whenever a application or UI sends a request to our gateway application using localhost, and in this case, in application.properties, I made the port 8003. You can do that by, using server.port equal to whatever port number that you put and that is open. I put 8003. So now whenever a user sends a post request to localhost 8003/event, we'll be accepting that message and checking the format, and if the format is correct, then we'll send that message to our Kafka topic. So let's finish this off. So we made sure that we know that we want to listen for post requests at /event, and then we want to make sure that we send a response back to the user. So we're going to use a response entity, and we're going to give it a type that we're going to send back to the user, which in this case, I'm going to make it a string. And I'm going to just give this a name called event. It can be anything that you want, but I'm going to call this event just to match. And I'm going to, as the parameter, I'm going to put @request_body, because we're going to be accepting a request body, and it's going to be placed into our model that we created, right? We want the request body that the user is going to send through this post request to match the transaction message model that we created, right? Because we want to send that transaction message directly to our Kafka topic. So we got to make sure that that message or that JSON that the user send as a request is in the same format that we expect for the Kafka message. So open up that curly braces. Then now we can utilize the Kafka producer service. So use Kafka producer service dot, and we can see the send method that we created. And the three things that it's expecting is the topic name, which is going to be a string, the key, which is going to be UUID, and then the transaction message, which is the model that we created, and it's what we're accepting as a request body. So first things first is going to be the topic name. If I go back to the Kafka config, we know that it's called transaction topic. So we're going to take that and we're going to place that here as the topic name. And then the second thing is going to be the key. So that's going to be UUID equal to, and actually let me import UUID because it's from the Java util. And then we're going to do UUID dot random UUID. So it's going to generate a UUID for us, and then we're just going to place that as the key. And then the last thing is going to be the transaction message, which we're accepting, so we can just pass it through. And then I need to return a response back to the user if everything goes well. So I'm going to return a response entity dot OK, which is going to send a 200 response back to the user with the message. And in this case, it's going to be sent. All right, cool. So now we got the main things out of the way. One thing that I want to add is a logger, right? We used the logger in the Kafka producer service, right? We created a variable called logger, and we used the logger factory and used the instance of the Kafka producer service to generate a logger to first log when there's any errors, right? After the asynchronous process is done, if there was an exception, then it will throw a log into our system with the actual exception message, or if it went through properly, then it's going to give us info regarding the transaction. But in our case, I want to see when a transaction was received and the UUID that was generated, because it provides some visibility, right? Because in the future, we can see, okay, we received that transaction at this time because we have visibility on the UUID that was associated to that specific message. So I want to have a logger for that. Now, before, like I said, we created a variable for that, but for this one, I want to utilize a annotation that Lombok has, which is called @SLF4J. And if that rings a bell, it's essentially the same thing that we use for the Kafka producer service. It's the same library that we used, but in this case, Lombok has an annotation for it that essentially generates all that for us. We don't even have to write that long variable like we did for the producer service. All we got to do is utilize the annotation, and now we have access to a field called log that pretty much has all that set up for us. So all we got to do is use the field name log dot, and now we can see that we have access to info, error, and so many other different methods that the SLF4J log comes with. So we can use log.info, and we're just going to print out we receive the transaction with the key and then I'm just gonna append on the UUID. So now we have visibility that we received the transaction, right? And now we have visibility on its key. So if we want to query based on the key, we can do that as well. Cool. So now we have a functional, REST controller set up. We have an endpoint /event. It's utilizing the log annotation. We generated a UUID. We're utilizing the producer service because we auto-wired it, and it's just going to send our message to the topic that we specify, which is going to be the transaction topic. And within the service, or within this method, the send method, is going to asynchronously attempt to send that information to the topic. If there's an issue, then it's going to let us know by throwing an exception and logging that. Or if everything is proper, then it's going to complete it, and it's going to log that that transaction was received with the ID, and we're going to get the status on that transaction. And all of this is possible because we set up Kafka. All right, we have a topic builder that set up a topic with the topic name of transaction topic. We set up that the partition has one, the replica has one. This is a single node cluster, so the replica could only be one, but we have it built. And we have the Kafka producer config, which has the server config of 1992, which we set up in our Docker Compose. And we have the serializer for the key, which is UUID, and the value is going to be a transaction message, but we're using the JSON serializer for that. So when the consumer receives it, it can deserialize the message that is in bytes, because we talked about that, how Kafka use bytes internally. So when the consumer receives those bytes, it can deserialize it, essentially turning it back into a transaction message that the consumer can understand and do things with it. And then that's all generated into a producer factory, which is then passed as a constructor to the Kafka template. And then we go back into the producer service. The Kafka template is just going to allow us to use a lot of built-in methods. And the built-in method that we use is just this .send, which has 3 parameters of topic name, the key, which we specified as a UUID here, and the message, which we specified as a transaction message, which we created. It's in the models folder. We know that it has these fields, this event type, and this status. So we did a lot of things in a short period of time. But yeah, this is the producer portion of it. We created our entryway into our application using the event controller, and now we can run this and see if it runs properly. And if it does, then we're good to go on to the consumer. So let me run that really quick and let's see what happens. All right, cool. And if this runs properly, then that means we're good to go. And it loves to throw a lot of messaging at us. And one thing that I forgot to say is this application is running on port 8003. I did change the default. Usually it's 8080, but I have other things running on 8080, or I have another thing running on 8080, so it's kind of busy right now. So you can go into the application.properties, which is in the resource folder, and you can use server.port is equal to whatever port you want that is open, and that would pretty much replace the default port with whatever you specified. In this case, it's going to be 8003. So now if I scroll just a little bit, I should see some Kafka configuration. So here you can see that it sees that the Kafka version is 3.4.1. You got the commit ID, you got the start time in milliseconds. So we are good to go. It didn't break. I scroll all the way down. I think it didn't break as long as I didn't see an exit code. All right, cool. So yeah, this application is running. So now we could get started on the consumer portion of the Kafka, microservice design, and hopefully in the end we can utilize the event controller, and then we can see that it's being logged, and we can see that that information is being received by the consumer. So let's get started on the consumer really quick. All right, so now I opened up the consumer application that we made, or that we got the template of originally during the Spring Initializer phase. It doesn't really take much. I just opened it up. If you have IntelliJ, you can just go to the file, open, and then you can just open it up. No problem. I even have the gateway still open, so if I need to go back to it, I could. And I actually do need to go back to it, because first, what we'll need to do from the consumer side is create a model of what we expect to receive from the Kafka topic when we do consume information from the topic. So the setup for this consumer is the same. You still have the .idea, you still have the .maven, you still have the source folder. So I'm going to open up this source folder. I'm going to open up the main Java, and within the com.twg.twg consumer package, I'll create a new package for storing my model, just like I did with the producer. Right, and then within this model, I'll create a new Java class called transaction message, just like I did with the producer, because I still want it to be the same format as how the producer is putting it onto the topic. So I can literally go back to the producer, go into transaction message, and I can literally just copy this whole thing if I want to. It's literally called the same thing. I still want the same annotations. I want all of it, right? And just paste that in. I just got to make sure that I import all that I need. And the cool thing about IntelliJ is that it imports it all for me, so I don't have to do it. So it's the same format. I still want the transaction ID to signify, the unique ID for the transaction. I still want to know what type of event it is when I do consume it. So I want to know if it's a withdrawal or deposit. I still want to know the amounts, and I still want to know the status. So this is all perfect for me. Now, if you want to add things, or if you want to create a new model and add things when you consume it, so you still have to have a model to consume it, but if you want to create a new model on top of it to send to another topic, say for instance, or to send somewhere else, you could do that, right? You can extract the information after you finish consuming it, and then send it over to wherever you need to send to, or store it into a database where you need to store, but you still have to consume the information first. So cool, that was pretty quick. We have the model that we need to consume the information from the topic. Now let's actually create the config for the consumer. So let me go in the same package of com.twg.twg consumer, or however you created your package setup. Just make sure you go to the parent package, put new package, and let's create a new package called config, because this is where the configurations are going to be set up just like the producer. Now let's create a new Java class, and we're going to call this Kafka consumer config, right? And the first thing we're going to need to do with this is we're going to enable, or use the annotation enable Kafka, right? So let's do @enable Kafka. And what this is going to do is going to allow us to enable the detection of Kafka listeners, because we're going to be creating a Kafka listener. So this enable Kafka is going to pretty much detect for any listeners that we create for Kafka. And just like the producer, in this file, we'll be creating a factory to add configurations for our consumer. We'll specify the key type and the message type. We'll set up the Bootstrap server config to know where the Kafka broker is, so it can fetch the initial metadata about the Kafka cluster. We'll assign the consumer a group ID, or assign a consumer to the group ID, because if you watched my Kafka Components video, this is my fifth plugin for that, so I would advise it. But we go over how consumers have to be in a group, so we'll specify the group ID here. And we'll specify how this consumer will deserialize the information from the topic. So that's enough talking. Let's actually get into it. So another annotation we're going to need is we're going to need the @configuration, just so that SpringBoot know that this is a configuration class or file. And then now we can start creating our factory, just like we did with the producer, but for the consumer, right? This factory is going to be the initial properties for the consumer. So let's do @bean, right? And then let's start defining the function for the factory. So consumer factory is what we're going to call this, or this is going to be the type, So consumer factory, and we're going to specify the ID and the type, right? So it's going to be of type UUID, and it's going to be transaction message for the value, right? We just created the transaction ID, so that shouldn't be an issue. And UUID, I got to import that from Java U2. And then this is just going to be called consumer factory. Then we can just open that up, and now we can start defining the key value pair for the configurations for the consumer. All right, so like I said, key value pair. So what does that sound like? Well, it sounds like a map to me. So let's do string, let's do object, and then it's going to be called props, short for properties, and it's gonna be a new hash map. Oops, I already generated that for us. Let's close that up. Make sure you import map. And now we'll start configuring what we need. So props.put, just like we did before. Now we're going to be using consumer config. And then we're going to do dot bootstrap server config. It's just going to be where our Kafka is going to be. So localhost 9092. And end that with a semicolon. So just like with the producer config, if I go inside, you'll see there's a lot of constants, and each constant has a string value. So right here we can see that this bootstrap server config, which is just bootstrap.servers, and we can configure that value for the bootstrap.server key to this value. So same concept. So let's go through it one by one. So then there's props.put, and just like I said, each consumer needs to be within a group, right? So we could specify a group ID for the consumer. So let's do consumer config dot group ID config, and I'm just gonna call this, I don't know, let's call it group ID. I'm not I guess creative enough for it, so I'm just gonna call it group ID. Just keep it simple. But just make sure that if you have a lot, right, make sure that each one of these are unique based on where you want your consumer to be. Next thing we're gonna do is we're gonna define the deserializers. Remember in the producer we created serializers for our message. So we had a serializer for the key, which was the UUID. So we used the UUID serializer.class, and for the value we use a JSON serializer.class, just so that we know, or Kafka knows, how to serialize information to turn it from the original value to bytes. And then now we're trying to get those bytes and deserialize it to the original type. So let's do that really quick. So let's do props.put, and we're going to be using a special type of deserializer, which is the error handling deserializer dot key deserializer class. And for the key, we know that it's going to be UUID deserializer dot class. So what the heck is this error handling deserializer? Well, if it fails to deserialize the content that we're trying to retrieve from the topic, the error handling deserializer returns a null value, and a deserialization exception is thrown into the header so we can know how to handle that, right? We know what caused the error and the raw bytes that it tried to deserialize, because like I said, Kafka deals with bytes. Is we serialized it, it's going to be in bytes. We will attempt to deserialize it, but if it's unable to deserialize it, well, they're just going to give us the raw bytes. So the error handling deserializer just helps us in the case of there was an issue and it's unable to turn the bytes into the original format. So we use the error handling deserializer for that. So that's for the key, and now we have to make one for the value. So let's do props.put error handling deserializer dot value deserializer class, and this is going to be a JSON deserializer. Boom, dot class. Nice. Now Kafka likes to put extra information into the headers when consuming information from the topic. But in our case, we don't need that information, right? We want to use our own setup, so we won't utilize the info that's being sent through the headers. So what I'm going to do is I'm going to put a configuration for the JSON deserialization portion, so we can use our own formatting for consuming the information instead of using the Kafka headers. So I'll be setting the use of the headers to false for JSON deserialization. So let's do that really quick. Props.put .json deserializer .use type info headers, and I'm going to set it to false, right? Because I'm going to set up my own way of consuming the information, and if I don't, it's going to use the headers information. And when I did some testing before, that always caused an issue, right? because the way that the information is formatted in the producer and packaged and how that's formatted is different than how the consumer is set up. So that usually causes an issue. So I just set this to false because I have my own way of structuring that message. And how I'm going to set that, or how I'm going to set the default type, is by assigning another prop so that it knows exactly where my message model is. So I'm going to do props.put, and I'm going to do JSON deserializer dot value default type, and I'm going to place where this, where my model is for the transaction message. Let me go in here, go up above, and grab this format right here. So I'm gonna do com.twg and just paste that in, models dots, and I'm gonna do transaction message, right? Because that's the default type I want to use. Let me see. Why doesn't it like this comma? Oh, because I have extra parentheses here. Okay, cool. And now I'm just gonna return a new default Kafka consumer factory, and I'm going to pass in the properties. So now we have the factory for our consumer. And now I enabled the Kafka, or I use the enable Kafka annotation to listen out for listeners for Kafka. So let me set up the listener really quick. So there are two message listener containers in SpringBoot Kafka. There's the Kafka message listener container, and there's the concurrent message listener container, right? So let me just hopefully copy and paste that in really quick so you have the name, right? So let me just do that, put it as a comment, right? Oops. Boom. The Kafka message listener container, and there's the concurrent message listener container, right? The Kafka message listener container, which is this one, receives all messages from all topics or partitions on a single thread. That does not sound efficient. While the concurrent Kafka listener or message listener container is used to create containers for annotated methods with Kafka listener, right? So it delegates one or more Kafka message listener containers instances to provide multi-threaded consumption, which is more efficient, right? You want to have multiple threads to listen out for many different types of events, because if that thread gets backed up, then that sucks. But if you have multiple threads, then we're good to go. So we're going to utilize the concurrent message listener container for creating a listener on our part. And we're going to utilize the properties that we just set. So let's start that now, right? I'm just going to erase this top part because that's not the one we're going to use. But just so you guys know, there are two. But I'm going to use the concurrent message listener container. So what we're going to do is we're going to create a bean. We're going to do public concurrent Kafka listener. And I'm going to spell it out because, the more you write things out, the more you memorize it, right? So container factory, right? And then for the key, it's going to be UID. And for the value, it's going to be transaction message, right? And I'm just going to call this Kafka listener container factory, and then open up parentheses and boom, open that up. It's a long one. It's let me bring that to the side, right? So that's a long one, but we got through it. So now we have a Kafka listener container factory, and let's set it up internally. So let's do concurrent Kafka listener factory, UUID, transaction message, and I'm gonna bring this onto another line. I'm gonna call this factory for short, and make this equal to a new concurrent, if I can spell that, concurrent Kafka listener container factory. All right, and for the factory, I didn't put an equal here. All right. So for the factory, I'm going to use the setter that it has, set consumer factory, to pass in the properties that we just made. We just made a factory, right? Right here, this consumer factory. So I'm going to pass that here, right? Because we know this consumer factory is just going to return a default Kafka consumer factory with the properties that we define. and then we're going to return that factory because it's expecting a concurrent Kafka listener container factory, and we're utilizing it by setting the consumer factory with the consumer factory that we just generated. And cool, now we have a listener that's going to use multiple threads. So that is the setup for the consumer, right? Hopefully that wasn't too confusing. If you have any questions, leave it down in the comment section below. So now all we get to do is create a service to go ahead and listen for any changes on a topic. So if a producer sends any information to the topic, the consumer should get a ding, little ding dong, to let us know that we got a message that we can consume. So we have this concurrent Kafka listener container factory. We'll now set up a listener that will listen for any time an item is placed on a topic. All we have to do is set the topic and group ID we want to read from. We'll consume it and we'll store it onto a transaction message object that we already created, because we're sending it as a transaction message object and we're going to consume it as such. So let's go into this package. Let's create a new package called services. And what we're going to do is going to create a new Java class called Kafka Consumer Service, right? And what we're going to do is do at component, because it's going to be a component, and we're going to do at SLF4J for logging, like we learned before. And what we're going to do is use the annotation of at Kafka listener, and open up parentheses, and now we're going to define the group ID and the topic, right? So let's do topics. Topics. There's a lot going on here. And we're going to set that equal to, open up some brackets, or curly braces, I mean. And then we're going to put in the actual topic name. So let me go back to the producer and make sure that I get that right. It's going to be transaction topic, but I don't want any spelling errors, so I'm going to copy that from there and paste it in here. And then now we got to define the group ID. Set that equal to. So the group ID will be group ID. Cool. And now we can set up the function. So it's going to be public void, because I don't want to return anything. I'm going to call it consume. Could call it Pac-Man, but I'm not going to do that. Be professional here. Transaction message will be the type that we're going to consume, and I'm going to call that transaction message. Open that up, and honestly, I'm not going to really do too much. You can do whatever you want here once you consume it, but I'm not going to return anything. I'm just going to do a log, right? I'm just going to use the log that this at SLF4J annotation allows us to use, and I'm going to do .info, and I'm just going to print out information regarding this transaction. So I'm going to say we receive the transaction with the ID, and then let's just do transaction message dot get transaction ID. And honestly, this is gonna get pretty long, so let me just boop and put that on a new line as well, and actually do another append. I want to get the status as well. The status is and I'm gonna append that. There's a whole nicer way to format this, but this is getting pretty long, so I'm gonna make this a little bit filthy. So I'm gonna get the status, put that on a new line as well, just so we can get some eyes on it, that we know that we consumed it properly, and it's a nice way of testing it. There's a lot of things you could do from this consumer. You can, like I said, now that you have an instance of transaction message, maybe you could create another model for placing information to a database. Maybe you have this plugged into a Postgres database. You have this SpringBoot application plugged into a Postgres database. You can create another object to format in a way that you want, right? You can take information from this transaction message, put it into another object to be used to store in a Postgres database, or you can take that information and send it to another topic, right? Maybe this is a fraud. It's a fraud transaction, right? Maybe you have it flagged and you want to send it to another topic that the fraud team uses, or the deposit team uses. There's a lot of things you could do with it. There's a lot of ideas that you could do with it. Just think about on a high scale what a lot of these corporations are doing with it. Companies like LinkedIn, companies like Netflix, companies like Pinterest. Like there's a lot of events going on. So just think about what these companies are doing and how you can implement it in projects that you are doing. So just be creative with it. In this case, I'm not being too creative. I'm just logging it out, but just give you some ideas on how you guys can think about using it. So cool. Now we got the listening on transaction topic. The group ID is this group ID. You could use this to override it to something else, but I'm just gonna keep it the same. And then we're just logging the information that we consume. So we have the producer, it's already running. So let's run this consumer, and then we can go into Postman and send some information so we can see if it actually works or not. Hopefully this configuration is set up. I think it's set up properly, but we'll see. So let's go into the TWG consumer application, or whatever you named it. Just find the main function, because this is going to be the entryway to your application, and just run it. And actually, let me stop it. I forgot to change the port. So I got to change to a port that I'm not using. Right now I'm using 8080. So let me go into the resource folder, application.properties, server.port, make that equal to 8004, right after 8003. And let me go back to that file, run it again. Obviously, after the first time you run it, you can press the play button at the top right here, but just for people who didn't see me do that, I'm just going to go back to this file and run it. And let me close these out. Hopefully it works. I'm crossing fingers. And it failed. Oh man. Let's see, where did it fail here? Okay. Invalid value for configuration. Key.deserializer must not be null. So let's go back to the configuration. Must not be null. So what is null in this case? Key value deserializer is there. So I'm guessing even with this error handling deserializer, it still wants us to use the actual deserializer property. So let me add that really quick. So let me go here. Just gonna copy this over and stack it here, and I'm just gonna use consumer config and dot, let me see, key deserializer class config, and let's do this one here, consumer config dot value deserializer class config. And now let's cross our fingers again. I'm just going to use this play button on the top right, and we'll see. Oh, I'm getting embarrassed today. Let's see. All right, so one more thing that I forgot to do was add the Jackson data bind dependency, right? Forgetting a dependency. Where did I hear that before? Well, that's okay. So what data binding is it allows us to convert JSON to a POJO. So we know that we're going to receive a JSON, we're going to deserialize the bytes to JSON and then convert it into a transaction message. So without that dependency, it will break just like it just did. So we're going to add the Jackson data bind dependency, and this should resolve this disgusting exception. So let me go over and get that dependency. Let me scroll over to the MVN repository, and it's already on the page that I need, which is the Jackson data bind dependency. Right now, the current version, or the latest version, is 2.15.2. I'm going to click on that, and I'm going to click on the dependency, and it's going to copy it to the clipboard for me. So I'm going to scroll back over, go to the pom.xml, find a nice spot before the test dependencies, paste it in, and I'm going to erase this comment. And remember, it is the Jackson or fasterxml.jackson.core, and it is the Jackson-databind. And make sure to click this load Maven changes, and it should start getting everything in sync. Cool. Now let's run it one more time and hopefully that resolve our issue. So the things that I needed to add was obviously this dependency, and then if you go back to the config, make sure you have a deserializer for the key and the value. So you can have an error handling deserializer, but also the consumer config deserializer for the key and the value. So one for handling errors and just one for just doing the normal deserialization. All right, cool. So no breaking at this point, and it seemed like, all right, cool, we're good to go. Everything was assigned. We see the listener listening to the assigned topic, which is transaction topic, and we see that the group ID is the group ID that was assigned. It's not very creative. It's not a very creative group ID, but it's there. It successfully joined the group. And now we have a running consumer. Let me check out the producer. The producer is running as well. So now it's time to test it out. Let's see if the producer, when we send the event to the controller, a post request, let's see if it will run it properly and send that to the topic for our consumer to consume and log. So now I'm in Postman, and what Postman is going to allow us to do is going to allow us to send in an HTTP request to our gateway service. So what I could do is in this drop down, select what type of HTTP method I want to choose. And in this case, I want to choose post because our gateway service is only accepting post methods right now, or one post method because there's only one endpoint. And I can specify the URL here. I know it's going to be running locally, and I know the port is on 8003 because I changed it from the default 8080 to 8003 for the gateway service. And I created a post endpoint of /event. So it's expecting a post request for /event, and is expecting a request body. So to specify the request body, all I got to do is click on the body tab here and then choose the raw radio button with the JSON selected. And now I can construct the request body. Remember, it is going to be matching the transaction message. So I specified that here by putting the transaction ID as a value, because the transaction ID is a long. The event is going to be either withdraw or deposit. So in this case, I chose withdraw. The amount is going to be a double. It's going to be like we're trying to withdraw money. So I put 100.0. Now, if you want to put 100.01, you can do that as well. But it's all up to you. And then there's the status, right? There's a series of statuses for the transaction message. So it can be pending, it could be canceled, it could be terminated. But in this case, I'm going to put pending. So now we have the transaction message and the post request all set up. So let's press send and see what happens. I have the producer or the gateway service running, so hopefully it accepts it smoothly. So just send it. Boom. So we see that we got a 200 and we got the response of sent, right? Because I only have it sending a string back, but if you want to construct an object, right, of data and some type of message, you can. But just keep it simple. I just made it sent. If I go back here, I see that, you know, Kafka started, the producer received the message. You can see that it wrote the sent. I see that the logger is working here, so the ID is 1. The transaction status is, you know, pending. That was sent. And now if I go to consumer, let's see if it actually took it. Yes. All right, cool. So we received the transaction with the ID of 1 and the status is pending. You see how all of this is working together. This is awesome, right? So now we have a producer that's accepting a message, an HTTP request. It's generating a random UUID. It's logging that information. So we see that the ID is 1 here and the status is pending. And it's sending that message to the topic and sending a response back to us. We got the 200 okay because it, you know, it got to this line right here. There was no errors. And then if we go back to the consumer, now we see that, okay, the consumer is running and it has a listener running, right? It has a listener going on, listening for any events. And when it does listen and see that there's a new message on the topic, well, we're going to consume that topic like Pac-Man, and we're going to log that information. And like I said, you don't have to log the information, right? We don't have to do what we just did here. We can do a lot of things with it. We can consume it, put the information to a database. We could do some logic, and based on the type of message, like we could do say for instance it was a sign up, right? We can send an email to the user. If that message has the email, we can send the email saying welcome to such and such product, hope you enjoy. Or there's a series of different things you can do, or you can send that message to another topic, right? Say for instance this is a fraud type of message, right? You can send it to the fraud topic. So there's a lot of cool things that you can do with it, but we see the power of this, right? Now we have the ability to communicate between services without having to send even an HTTP request. It could just be through a Kafka pipeline, a Kafka topic, right? And whoever wants to consume from that topic can consume from it, right? Whoever needs to consume it can consume it. So now we're able to communicate between two services with no problem, and the speed is great. So hope you found that useful. Hopefully you found that enjoyable, and hopefully you can take what you learned from this and make it 10 times harder, 10 times more useful, right? We can create a multi-node process, right? We can have more than one broker, more than one instance of Zookeeper, have multiple services, store information in a database, send it to another service. There's a lot of things you could do. Send more than one message, right? Send thousands of messages, right? So there's a lot of things you could do with this, but hopefully this gives you a understanding of how to set it up and the power of it. And if you have any questions, leave it down in the comment section below. Thank you.